When you're solving an equation such as x plus 2 equals 7, what you want to be able to do in the end is find out what x is equal to. Now, most of you will be able to tell just by looking at this what x is equal to, but this is an easy one. So I want to show you the steps that you're going to apply even to more complex questions like this. The goal is to have x equal to something. So you just want x on one side of the equation by itself. Right now you've got x plus 2, so you've got x plus, let's say, two other things. Let's use just dots to represent them, equals 7. Now we don't know what x is, theoretically, but we want to isolate x by itself. We want x just by itself, so we want to get rid of these two things that we added. So we can actually subtract those and just be left with x. So if I have x plus 2, and then I take away those two, I'm just left with x. So notice I said I took away those two. But because this is an equation, whatever we do to one side of the equation, we must do to the other side of the equation to keep it equal or balanced. So in effect, I did x plus 2 and then I subtracted 2. So because I subtracted 2 on this side, I also have to subtract 2 on that side. So over here, because I've got 2 minus 2, which is 0, I'm really just left with x. But on this side of the equation, I'm left with 7 minus 2, which is 5. Now, the one thing about solving equations like this is you can always go back and substitute the value in the original equation. So if I substitute 5 over here for x, I indeed get 5 plus 2 equals 7, which is exactly the right answer. And the same with an equation like this, x minus 5 equals 2. Well, I subtracted 5 over here on this side. So in order to get x by itself and make this 0 over here, I have to do the opposite operation. Opposite of subtraction is addition. So I add 5, and then that's going to equal 0 over there. But because I added 5 to that side, I also have to add 5 to this side. So we can see again that x equals 7. And I can go back and substitute. 7 minus 5 equals 2, and that's correct as well. So you can always go back and check. And I'm just going to go through a few of the other ones that are on the lesson. So we have one, 4 times x equals 12. Whoops. Equals 12. And when you see 4x, you know it means 4 times x. So again, we want to isolate x by itself. So the opposite of multiplication is division. So 4x divided by 4, and over here we're going to do exactly the same thing, 12 divided by 4. So when we get 4 times x divided by 4, because this ends up being 1, we can just say that x equals 12 divided by 4, which is equal to 3. So let's go back and substitute again. 4 times 3 is 12, and that's exactly the correct answer. And in this one, we've got to take a look at a couple of things. First of all, we've got 3 times x minus 2 equals 10. So let's start by getting rid of that 2. 3x minus 2 plus 2 equals 10 plus 2. We can get rid of all of this because this is equal to 0. So we just have 3x is equal to 12. Now we've got multiplication here, so we have to do the opposite of 3 times something, which would be dividing by 3. 3x dividing by 3 is equal to 12 divided by 3. So because these two cancel each other out and turn into just 1, we can say that x is equal to 12 divided by 3, which is 4. Let's go back and substitute. 3 times 4 minus 2, that would be 12 minus 2 equals 10, and that is correct also. And in the next one, we have x divided by 4 equals 3. Now we know that the opposite of division is multiplication, so we're going to multiply on that side. We're going to go x divided by 4 times 4. so those will cancel each other out, is equal to 3 times 4 because we have to do the same thing to that side. So we have x, and those cancel each other out, equals 12. And we go back and substitute it. We get 12 divided by 4 equals 3, which is indeed correct. Now again, in this example, we've got two operations. We've got division and we've got addition, so we're going to take them one at a time. So first of all, x divided by 2 plus 3 minus 3 equals 4 minus 3. We're doing this first to get rid of that, and because we do subtracting 3 here, we have to subtract 3 there. So we have x divided by 2 equals 1. Division, the opposite of division is multiplication, so let's multiply that side by 2 to get rid of it. X divided by 2 times 2 equals 1 times 2. Now we've got just x left over here. The 2's cancel each other out, so we're left with x equals 2, and we go back and substitute. 2 divided by 2 plus 3 equals 1. That would be 1 plus 3 equals 4, which indeed is correct. Now in example F, we have x's on both sides, so that's going to be a little bit of a problem. We need to get our x's all on the same side, and we need to get our constants all on the same side as well. So the first thing we're going to do is get rid of this 4x over here. So because it's an addition here, 4x, it's a positive, we need a negative over there. So on this side of the equation, I'm going to go 4x minus 10 minus 4x. So because I did subtracted 4x over there, I'm also going to subtract 4x over here. Okay, now because I've got just negative 10 left over here, but because I've got 6x and then a minus 4x over here, I can combine those like terms into 2x minus 6. Now I've got to deal with this minus 6, and so I'm going to take 2x minus 6 plus 6 equals negative 10 plus 6. Same thing on both sides. I end up with 2x equals negative 10 plus 6, which would be negative 4. Now I have to deal with this multiplication. 2x equals negative 4, so I'm going to divide by 2 over here to get rid of that 2, divide by 2 on the other side, and I'm left with x equals negative 4 divided by 2, which is negative 2. I'm going to go back and substitute. 6 times negative 2 minus 6 equals 4 times negative 2 minus 10. And that's going to be equal to 6 times negative 2 is negative 12 minus 6 is equal to, and over here I've got minus 8, negative 8 minus 10, so negative 12 minus 6 is going to be negative 18 equals negative 8 minus 10 is also negative 18. Always go back and check, and then you'll be sure that your answer is correct.